So my name is Hausmann, and I'm actually glad to be back here again. I looked a bit in the past. I see this is the 6th time that I'm presenting at Dev Days. And at the age of, at least in Germany, at the age of 6, that's when you get into, that's as a kid you go into school, and that's when things become serious. So on that note, I'm going to talk about the QML engine, a little bit about review and the like. But the background for this is the reason why I'm presenting this in the first place is because for us, I work on Qt full time, and for us, Qt Quick and underlying QML is one of the 3 main pillars of Qt for application development. We think this is important, and we think this helps people to write applications quicker. However, as we're working on this, it's changing a lot. We are changing a lot on the engine. We are only 2.5 people on it, but we're changing a lot of code. We are doing a lot of stuff in it. And most of the time, you should only be pleasantly surprised with things working better or not, but sometimes we change things. And so I'd like to show a little bit about it. So the goal of my presentation now is that you have a better understanding of what we're doing, what we have changed, and what we're going to change. Because fundamentally, if you use technology and you have a better understanding how it works inside, it'll be easier to use it. It's as simple as that. But that also means that if you have questions about how things work inside, please ask me. We'll do questions, I think, at the end. That's probably the easiest. But if you have a quick question, don't hesitate to interrupt me if you think something is quick to answer. So a quick outline for this hour, roughly. I want to talk about 2 things that we've worked on in the past. We did a lot of stuff since last year, actually. This is sort of connecting to my presentation last year, where I talked about what we did the year before. So now I'm talking about what we did last year. I'm talking a little bit about some of the optimizations we've done inside. For the curious, I'd like to talk about one feature that a fellow colleague implemented last year. That is now in Qt 5.2 and 5.3, which is what singletons and QML. And I'm then going to move on to some of the things you will see in the next release in Qt 5.4, and some things that we'd like to do in the future to make it a bit easier. This is where we get then to the zone of where I really am curious about feedback as well, because this is going a bit into the where would we like to go. Does this make sense to you guys or not? And finally, I'm going to spend the last part talking a bit about the Qt Quick compiler and the idea of compiling QML files ahead of time into your application. And I'm going to demonstrate some things there, and you get a bit of an idea of how this thing actually works, I hope. So let's dive right in. I'm going to go right into a brief recap or a brief detail of how names are resolved in QML. Name lookups, we call it. So let's just look at an example, QML code here. Let's see, I can highlight lines here. So what we have here is a QML file with a row. It doesn't matter that this is actually you can run this thing and it shows a bit of text side by side. But what I'd like to go through is a bit how we resolve a couple of things here. Because then I can explain what we did to make it fast. So we have a QML file with a property that is called title here, or we have an object that has a title property, and there are some text elements in here. There's 1, 2, 3, and this is also a text element. Despite the evil name, it is a text element, you'll see. And I'd like to start with the first text element, which gets a text from this expression label.text. And when the engine sees that it should determine what the text should be, what the string should be, it looks at label.text and it has to find out, so what did the programmer really mean with this? And as you may know, if you have used QML before, this refers to the text property of an object that has the name label, which happens to be down here. So we've given it the identifier label, ID label, and this is what it resolves to. This is what we call an ID lookup. A lookup of a name by a lookup of an object by ID, by its identifier. The second type of lookup we do is what we call a scope lookup. So in this example, the resulting string is a concatenation of a constant string. I'm located at position, and then there's x there. Now the question is, what is x? What does x result in? Where does x come from? And the answer is that x is a property of the object that is currently in scope. This is called the scope object, and as it turns out, that is this element itself. This text element is a general Qt quick item, which has a width, a height, it has an x and a y property, the position and the dimension of the screen. So in this example, x is resolved to, there is no object that has the identifier x. So there's only one that is called label, but there's none of x. So the next thing is that we'll look into the properties of the current scope object, and that is the text element, and that one does have a width, height, y, and it has an x property. That's the one we're looking for. So this will result in a string that says I'm located at position and the x coordinate of this item. And then the third type of lookup that we have, this is sort of sometimes a bit more confusing when you read, but it's very convenient, is when we look up a property not in the current scope object, but in the outermost object. This is also called the context object. So here, title, there's no object that has an identifier title. Text, the text element itself here does not have a property called title. Nope. But the outermost object, the row here, that one has a property called title. That's the one we declared ourselves. Sorry? Well, the question was whether this property is found in the parent or in the outermost, and the answer is in the outermost. So if this text element here is nested deeper inside, I should have probably done that, then it would always look up in the outermost. So this is not related to the parent of the item, but it is related to the outermost object. So those are the three types of typical lookups when we try to resolve a name in an expression to what it actually means. So in these three cases, we try to determine in a string always, but we compose the string out of different properties. There's a fourth example, and that is called the evil text, and that is a pattern that is supported in the engine that is sometimes useful, but is generally not very advisable. Which is when we look at what evil text is, it's stored in a separate file. This shall be evil text, and in here this is also a text element. But we can say actually label the text here, and this may seem a bit odd. You might ask yourselves, where is this label coming from? And if you use evil text as a component somewhere else in your application, it's probably not going to work unless the QML component that instantiates this evil text has an object named label. It has to have that. Then it works. So what happens is that label is not found in this QML file. It's not found as a property of text. It's not found in the outermost object. It's going to look into the parent context, and that happens to be this file. So while this does work, it is something that is tricky and only rarely useful, but in particular it's slow because it will cascade and may have to cascade through many contexts. So a brief recap, or actually a complete summary of how names are resolved in QML. So I didn't mention that earlier, but the first thing that actually happens is that we look, is the name that we're trying to resolve, is that a member of the JavaScript global object. This is when you use math, for example, math.signers or something like that. And there is also a special handling for names that start with an uppercase letter. I didn't have that in an example, but you may have used that yourself if you access enums and the like. So names that start with an uppercase letter, they're treated specially. This is where we look in imports and other things. But after that, I would say, regular process of resolving names resumes, and that is, as we've seen in the example, it begins with looking for objects with a given identifier. Then it looks for properties in the scope object, in the nearest surrounding object, you can say. And if it still can't find what we are trying to resolve, then it's going to look in the properties of the outermost object in the current QML file or QML context. And if that doesn't work, then we're going to do a loop. We're going to go to the QML file that embedded us, and so forth. So it's actually a loop, or also called a context chain. You may see that maybe sometimes in the documentation. So in the implementation of this, and this is sort of the standard, we resolve names, strings, to what they actually mean. And what we've done last year is we've spent quite a bit of time of trying to make this faster. Instead of doing lots of string comparisons in this loop, we're trying to resolve these names, like label or like X, like you've seen, or title. We try to resolve it to an integer identifier, to an index in an array, because if you know an index in an array, you can access it very fast. If you're trying to find an element in an array with a specific name, you have to go through all of them. It takes longer. So we have done optimizations, as when you try to look up an object by ID, or when you try to do the other case that I explained, then we resolve those to integers and can deal with them faster at runtime. And how this looks, I'm going to show you as an example. This is an example of our intermediate representation in the engine that we have. So we take those QML expressions and we compile them to an intermediate. It looks like an intermediate programming language, really, and it kind of is, but it's an intermediate representation. And so if we look at label.txt, this was actually before we started working on this. So in 5.2.0, it's still like this. Last year, label.txt results in code, in intermediate code that looks like this. So there is a expression that says there's a variable with a number. We don't give variable names; we give them numbers. We're lazy like that. So variable 0 is of an arbitrary type var. We don't know what it is, and it shall be resolved from label. So in this line, there will be a call into the QML engine that will go through this loop that we saw earlier, the traversing the context chain, looking up, can we find it? Is there an object called ID? No. Is there a property called label or not? And once we have the label resolved, then we're going to ask it for its text property. It must have one, or it better have one. And then we're going to return it, and then assign it as a result to the string that we're going to show. And what we do nowadays instead is that we already know at compile time when we load the QML file, hang on, somebody's trying to use label. And I've seen that there is an object further down that has the identifier label. Let's do something a bit quicker. So instead, we already know that we're trying to resolve an object with a given identifier, and we can look it up. So in the current code that we generate, we have an array that has all of those objects inside, or reference to the objects inside that we've given an identifier. And because we know that this is a fixed amount, it doesn't change at runtime, we can also give it we know where in this array it is. So as it turns out, there is only one in our example that had ID, so there's only one. This is index 0. So what we do instead is, in this built-in ID array, which has all of the objects that have an identifier or a name, we take the first one. This looks like an array access, right? There's a lot of curly braces, but the square brackets, this is the array access, and that's where we get the index 0 out of it. And because we look at these things now at compile time, we know that what's coming out of this array is not just an arbitrary object of any type. No, we know it is a qquick text. We know it is a text element. And because we know it's a text element, we can also resolve the text property already at compile time to the meta property index. So we do this, what we normally would have to do at runtime, which is this index of property, and try to resolve the term text, the string text, to what index it is in our list of properties in the Q object. And as a result, the after case has more lines of code. You might think this is slower, but it is quicker because we don't have to look up things by its string. We don't have do the string comparisons. Instead, we get from an array, we get the first element in the array, and then we get an object out of it. From that object, we ask it, give me the property number 43, and we already know it's a Q string. And this is a quicker way of resolving names. This is by ID. We do the same thing also for scope properties. So if you look at this example again, this is the second one we had earlier. In the old code, we took one string, we stored it in a variable number 1, we created a variable number 2, and we just assigned x to it. And when you assign something like that to it, it means go back into the runtime of the QML engine and do this loop that we described earlier, traversing the context chain, trying to find out what is x. And that's a lengthy process. And once we have x, and we don't really know what the type is, unfortunately, we just try to concatenate it with a string, and we sort of force it into a string as well. And nowadays we can do a bit better. We already know that x, the x property up here, is not just something that could be anywhere. No, we know it has to be, by the definition of the language, it has to be a property of the current scope object. That is a special variable that we always set appropriately when evaluating this expression, and we know it's a QQuick text. And again, we can do from this object that we've received earlier, we can look up the meta property number 5, please. We don't have to ask, give me property number x, property with the name x. We can say, oh, give me right property number 5. That is going to be the text. And we know that we actually know that it is a double, importantly. In this particular example, that doesn't have much of an advantage, because concatenating a string and a double, there's not much we can do apart from turning the double into a string and then putting them together. But if this was instead a loop where we did calculations, adding up x coordinates or so, we can use that information to our advantage and know that, okay, we're adding up doubles. The result will also be a double, and we can store these things in processor registers instead, because we know it fits. So those are the two types of. These are two examples of how we do optimizations nowadays. Is when we resolve names, and this is also why in your QML code you should do these types of lookups, either by ID or by the scope object or using properties from the root objects. But don't do this. Use a named object from an outer QML file, because that will always have to go back to a much slower code path. Instead, define a proper interface with a property that is set, for example. So, summary. What we're trying to do very hard is avoid string comparisons at runtime. So, label and x and what. We try not to compare this by names, but we try to just, at only one single time at load time, find out what is it. What is x? X is a meta property of a specific index, or label is the fifth object in our list of named objects. And then we can do lookups much quicker. We can resolve names quicker, and QML will run faster. Simple as that. All right. Next feature I'd like to talk about. There's two features. This was the first one we spent a bit of time on. There's a couple more, but this is the second one that I think is a bit of a highlight, because I think it's a very convenient thing to have. QML always had the ability to create singletons. So singletons are these objects that you have only one single instance of in your program. You can be sure that there will always be only one, and then you can access it also directly. And the way you could create singletons in QML is that, or access them from QML, is that you'd have to create an entire QObject subclass, and you have to expose it through using a special QML register singleton function, or you can also create you can register a factory function where you can, that is called only one single time, and then you return a QJS value or Java. You can return any arbitrary JavaScript object. And this is nice. This works well. We haven't changed that. No worries. But we found that sometimes it would be really nice to also create those singletons not only in C++ but in QML itself. And what we have implemented looks like this. This is how you would actually create it or use it. So suppose we want to have settings. Suppose we want to centralize settings. Settings is usually something that you have only one instance of in your application. And so I'm going to create a settings QML file. That shall be my singleton. I'm going to tell the engine that this shall be a singleton by saying pragma singleton. This is a new keyword that we've introduced, and that is a statement that there should be only one single instance of this. But after that, it's a regular QML file that defines a new type, but it will be instantiated only once. So in this example, I'm creating a non-graphical Qt object, and it shall have just a property width. This is just an idea of making your application, example of making an application a bit more resolution independent by saying I'm designing it for all my graphics, etc. are designed for reference width, screen width of 1280. But when I'm actually going to run on different screens, I'm going to have to scale all the widths in my program according to the width of the current screen relative to what I've designed it to. So I'm introducing a width scale property. And the nice thing is then I can access this width scale property from everywhere, and it will be initialized only once. It has to be also calculated only one single time, because the width of the screen doesn't usually change. I mean, people are still introducing flexible displays, but I haven't seen sort of the displays that you can. This will have to change the moment Apple introduces that, but until then, this is safe. So the only other thing you have to do is you have to create a QML dir file, unfortunately. And there you have to declare, like with any other type, you have to declare it. And you have to use a singleton keyword here to say my settings in the module that the QML dir file belongs into. My settings shall come from, in version 1.0, it shall come from my settings.qml. So you can actually version QML files. In the long run, I'd like to actually, so you see there's singleton mentioned here and also here. In the long run, I'd like to get rid of the second one, actually. I think it would be nice if you could generate those QML dir files. They're not very nice to write. But until that is done, you're going to have to do it like this, unfortunately. This definitely works, and it'll continue to work. So the way you can use those singletons then is in JavaScript or in other QML files. In JavaScript files, you can import them with this, for example. You can import.mymodule. This is where the QML dir file lives as my module. And then you can access it via the module namespace. So mymodule.mySettings, that was the name of the singleton. It'll be created only one single time, and then we access the width scale property.
Simon, is there any advantage of doing this to store global variables instead of using a JavaScript include, which can also be a pragma library? What's the difference?
So the question is there an advantage of doing this over just having a JavaScript file with pragma library? And the answer is that currently there's not much of a difference, but conceptually there's a big difference, because if you have this in a JavaScript file, you don't know what the type of width scale is. Right? You don't know what it is, but in the QML file, thanks to the type nature of QML, we know that width scale is a double. So we can actually make use of that then in the future and say, oh, we have a double, we're multiplying it with 200, the result will also be a double, and we can generate better code.
You don't get property changes.
Sorry?
You don't get property changes.
The question is, or the statement, in fact, was a claim that there was no property change.
No, inside the JavaScript file,
oh.
you try the singleton code in JavaScript file, you don't get property changes.
Right. Yeah, if you're interested in notifications, then declaring them as properties in QML allows you to get notified if in the unlikely event of your screen changing. Right. So as a summary for this feature, it's a convenient way to centralize data or functionality. You can also put functions in there, obviously, not only properties. But it can be easier to write because you don't have to compile them, and there's no factory function that you write with a correct signature and you have to return magic things. And what it will do is it will allow us to do some pretty cool optimizations, I think. For example, if we go, I'm going to go back to the settings QML now. Here, this width scale property, if you really think about it, as we've established, screens cannot be changed, is really a constant. So what I would really actually be writing here, if my presentation program would allow the corresponding resolution, which it doesn't, I would write here, I would write read-only property. Because I know that this is a constant, it cannot change. And if we know that this is a read-only property, later then in using it, we will be able to do inlining here. We can inline this, because the code here that I'm highlighting will be generated at runtime. And at runtime, we know what the resolution of the screen is. So at the runtime, this width scale, it will be a constant, and we can do the multiplication right at code generation and generate code that just assigns the final width to this effective width variable.
I was wondering about your import my module. Did you use my module.mySettings? Shouldn't be just my settings?
Jürgen is claiming that this is incorrect syntax. I don't think it is incorrect syntax. I believe this is correct. Yes. This would. Oh yes, and he is correct. Yes, well observed. Somebody's paying attention. Thank you. Give him a hand. Yes, the my module here is incorrect, or I would have to write my module as my module, which looks a bit awkward here. Yes, correct. This is. I better fix this for San Francisco.
I see you there.
Yes, he will be there and checking up. Right. So one nice thing is that by defining this, by defining this thing in QML, and if we'll add read only in front of it, we'll be in the future we'll be able to actually do inlining, for example, of constants, and that is kind of a nice thing to be able to do. All right. I'm running a bit behind, actually, but I'm going to speed up a tiny bit now. I'm going to talk about two things that we have changed just rather recently, one thing, actually, that we have changed just recently that is a bit of a behavioral change. And I'm going to talk about this nebulous, crazy idea that is partly based on what the man in front of here implemented about interacting with C++ structures in QML. So the first thing I want to talk about is QVariant in JavaScript and QML. This is a little example file here where I'm declaring a variant property. And variant, as you may know or may remember, a property of type variant is mapped in C++ to QVariant. So far, so good. So if I were to assign the value 42 to it, it's going to turn into a QVariant int. If you were to instantiate this thing and get a reference to it from C++ and you read the value property, if this was the only line otherwise present in the file, you'd get a QVariant of type int back. Similarly here, you put a string in it, hello, it's going to turn into a QVariant string. But if you add a JavaScript array here, this is a JavaScript array definition with 1 to 3 elements, it will result in a QVariant list. It will result in a QVariant list, not a JavaScript array, but a QVariant list. Similarly here, this is a more complex expression. It could be written with an object literal, but I'm doing here for illustration. Creating a new JavaScript object, we're creating two new properties, one called direction up and the level 100. This could be an elevator. And then we're going to assign it to the value property. And when you read this thing from C++, you're going to get a QVariant map with two entries, one of them called direction and the other one level, and then those will be, again, pointing to QVariants, one with a string and one with a number 100. This is how it was up until Future 5.4. Unfortunately, we've had to change this. This is a brief summary again, what I just said. Primitive types in JavaScript are mapped to the primitive QVariant version, so double, string, etc. are to variant, but JavaScript arrays and objects are turned into variant lists and maps. And this creates, surprisingly enough, this creates problems. Quite a few of them. We had quite a few bug reports around it. Fundamentally, it causes a loss of data. You lose the information that there was a JavaScript object behind it. You lose data inside those JavaScript objects that cannot be represented otherwise. And it is quite unexpected in some cases, with alias properties, for example. And to top it all off, converting this JavaScript object or JavaScript array to a QVariant list or QVariant map is actually a bit of a tedious thing to do. It takes time. You have to allocate a QVariant map first and then insert the keys when you already have the JavaScript object. So because this created some problems, we're going to change behavior slightly. in Qt 5.4. And what we're going to do instead is that for JavaScript objects and arrays that you want to turn into a QVariant, we're not going to flatten them out anymore. We're not going to recursively change them anymore, but instead we are just going to store them as QJS value in the QVariant. So the result is that if you look back at this example, this will remain a QVariant int, this will remain a string, but this will now turn into QVariant QJS value. And this will also result in a QVariant JS value, but if you ask the JS value if it's an array or if it's an object, it'll return the correct thing, the correct value. But the data is preserved, and what we also do is that we, for convenience, we have conversions registered. So if you take a QVariant that has a QJS value inside and you call toList or toMap on it, then you will get a QVariant map, and you will get a QVariant list that is flattened as before and that doesn't have everything inside anymore. But it is this old behavior that you can still get that way. But this is an important change that we really had to do, because a lot of people reported actually problems with this, with the old behavior that we actually destroyed entire objects there, and you wanted to pass function pointers in JavaScript around, and they were just suddenly destroyed. So we had to change this. This is also mentioned in the changelog. All right. Now I want to talk about a dream, actually. It is a bit of a dream, because it is something that I've wanted to do actually for a long time, and I couldn't quite figure out how. And then our Belgian friend in front had a brilliant idea, and I'd like to build on that. So I'm going to present you with an idea that we're having and that we'd like to do, and if you have suggestions of whether this is good or no, just don't do this, then let us actually know at the end of the presentation, perhaps. Let me introduce the example first. The example is we're just going to model an office desk. Office desk, if you work in cubicles, that's the thing your boss has in his office on the outside. It's this long thing. I'm going to model it very simply. I shall say an office desk shall have a monitor count, number of monitors. I'm an engineer. I have at least 3 screens. My boss has only 1, so it's a variable. There's an owner. A desk has a current owner, can be changed. And since I drink coffee, I want to know whether this desk that I might get in the future or not has a coffee cup warmer or not. This USB power thing is quite convenient. So this is a simple C++ structure, mapped as an example here. And if I wanted to use that in QML, I'm going to have to ask myself, so how do I make this tiny little structure available in QML? Well, option number 1 is I can actually create an entire Q object with Q property and invocable functions and everything. But that feels a little bit overhead to have an entire Q object for every. Suppose I have a really big office. Suppose I'm like Intel or some other big company, and you have hundreds and hundreds of office desks that I want to model in my application. It kind of feels strange to allocate lots of Q objects for this. I could try to convert the properties by hand every time, but that doesn't feel quite right either. So the common problem of having custom structures in your application that are specific to your use case and using them conveniently in QML is a bit annoying. And the proposed solution that we're having in mind now consists of 2 things. When going from C++ to JavaScript, we wanted to use a feature called gadgets. If you attended the previous talk by Jendrik, he mentioned that towards the end. And when going back from JavaScript to C++, I want to use a concept called structural typing. So the way this would look like, these are just words, better to look at the code. We're going to change our little office desk slightly. It's still just a C++ structure. There's no extra subclass introduced or anything. But we're going to use, in typical Qt style, some extra macros that do not expand to anything. So they won't bloat up your structure. They won't add any fields. But Mock will take a look at them and see, he's trying to do something there. So in this case, we're trying to introduce a so-called gadget. Not a Q object, but a gadget. A gadget is a Q object that is not a Q object. It doesn't require the use of Q object as a base class, but it allows you to declare certain features in the class, and the mock will still generate this extra meta information. So the idea is to, or the plan in fact, and it exists already in Garrett and a series of patches, is to add support for declaring properties in QGadgets. And the idea is then to be able to let the mock generate code that you can query those properties from any pointer to an Office desk at runtime. And that is all the engine needs in order to dynamically read arbitrary Office desk objects. So the way this would look in C++ is you just create an Office desk object from somewhere, but you would just wrap it into a QVariant. It has to be also a registered meta type. Actually, I forgot to put that into the slides. According to Olivier, that's not even necessary anymore. All right, from value does it implicitly, I think, right? But yeah, we would just pop this into a QVariant, and then we could, for example, expose it to QML through a context property. That would be one way. And what would be happening behind the scenes now, that is at least the idea, is that the QML engine is going to look at this variant, and it's going to see, okay, it's not an integer. No. It's not a string. No. Oh, this is a gadget. I've seen this before. And because the mock previously went through this gadget structure, it knows that, an Office desk shall have 3 properties. It shall have a monitor count, it shall have an owner, and it shall have a coffee cup warmer, or at least something that indicates whether there is one or not. And with that knowledge that is registered in a central place in that Qt meta type registry, the QML engine will then be able to see, okay, this is a QVariant, and I don't really know what's inside, but I know that it should have 3 properties. They should be of this type, they should have this name, and this is how I can read and write the values. Great. So the JavaScript engine then can create a wrapper or a more lightweight object, or even an entire JavaScript object that just has the same properties. It can do the right thing, the kind of thing that it already does automatically if you put a QPoint into it or a QRect or something like that. The QML engine can already do that, but it can't do it with our Office desk. But by extending our type system with support for properties for structures and registering them in the central place, we should be able to map your custom C++ structures to QML and then easily access them by value, effectively. So how do we go back? Suppose we have a JavaScript object that has properties, and we want to pass it back into the C++ side where we know that's going to be an Office desk. The suggested solution is called structural typing or duck typing. Like if it looks like a duck, it walks like a duck, so it must be duck. Similarly, if the JavaScript object that we want to convert to C++, if it looks like an Office desk, it has the 3 properties that we're looking for, well, then let's just create an Office desk. The meta-type system is clever enough that it allows us to instantiate a new Office desk, and it allows us to dynamically set those 3 properties that we need to set. And after that, we have a pointer to a piece of memory that has exactly the layout of the structure that we've declared, our own custom structure. And then we can pass it on to the application. So this would look roughly like this. We'd have somewhere in our C++ code a Q property declared, for example, Office desk, and it shall be a desk property. Actually, there's a typo. Anyway, and so in JavaScript, we could, for example, use a synchronous XML HTTP request. I know it's very evil, but nevertheless, and we could query the current boss Office inventory and ask what's the Office desk of my boss currently, and we'd get JSON back, because that's kind of a hip thing to do nowadays. And we'd have a data, and at this point, this data variable is really just a JavaScript object that happens to have 3 properties that we expect it to have. But it would be really cool if we could then also assign, like if suppose there's a current Office object and has a desk property, it would be really cool if we could just assign this simple JavaScript object to this property, and the QML engine would see that, okay, I have a strange JavaScript object here, I should assign it to this property, and this property is of type Office desk. But I know that the Office desk has these and these properties, well, let's just go ahead and create it. and do the conversion as a result. This is currently something that's not possible with your custom types, and that's something that I think would be really nice to have. And this is sort of our plan of how we'd like to try it out. Quick question there?
Two questions. When I force a C++ to a QML example, it's also possible to pass in pointers to custom structs, so that you don't have to copy the data into the QVariant, push it to the engine, but that the engine accesses directly objects that stay inside C++.
So the question is whether you could pass pointers instead of by value. And I think conceptually, yes. I mean, QVariant is just nothing else than a pointer. So in principle, I think that should be doable. We'll have to negotiate the details, but I mean, in principle, why not, right?
What kind of semantics do you have right now? Value semantics?
Currently, none, because you can't put your own custom types in it, right? So this doesn't work. I'd like this for this to work, but currently there are no. Yeah. So I think rightful statement here is that one of the disadvantages of this is that you wouldn't get a notification if a property changes on the C++ side, and that is true. But that would then suggest that it would have to be value semantics. It would have to be an actual value conversion.
Could you, in that case, have the QML code and modify the attributes because you know you're modifying it inside a struct to fire a signal for the container?
Oh, good thinking. So if I understood this correctly, what the man in the middle there is suggesting is that the engine would detect that when JavaScript writes into a property, it could also emit, since it knows it's writing a property, it knows it's going to change, so it could sort of, by itself, emit a notification signal. Maybe.
Then it has to be a pure object.
Well, the question is, does it have to be a object? But not necessarily. It depends on whether this thing is accessible from the C++. It only has to be a Q object if somebody wants to connect to it from C++. But notifications inside the engine don't have to be based on Q objects and C+ slots. Oh, the hands are coming up. Okay.
Say, for instance, what happens if you are not assigning a duck but a fox to the duck?
Yes. Right. So that is, if this was a duck instead of an office desk, by chance, say the server has been compromised and isn't returning proper office desks anymore. We have to determine what we want to do there. If we want to, throw an exception or create a null object instead, or like an empty office desk, or that is something that we have to determine. Indeed, it's not entirely obvious what to do there. I think Tobias was first, and then.
I've got a comment to that.
Okay.
Because on the QML side, you do have that concept of types that you can't assign a certain type. So I would just expect that it follows the same exception as when you assign the wrong type to a type property.
Yeah, I think it's a good idea actually to say that this is similar. Thanks. This is similar to when you assign the wrong type to a property in QML, then you'll just get actually it will throw an exception. You will see a warning output. Cannot assign blah 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 to property of type XYZ. So in that case, that could be one way of handling it, of course. Tobias?
Will the duck typing also work with nested structs? So I assume if you get back a JSON object, it might not be just a flat list, but you might have it nested with
So the question is, would duck type or would this type of typing still work if it was a nested structure? I think in principle, yes, because if you think about the corresponding, so if you look at this, I'm going back to this. If you look at this here instead, you'd have not a property of type QString, but a property of type that is another gadget, and that's enough, right? I mean, you can then.
Do you see any performance problems with looking up all these types and finding the right?
Whether this is going to be a performance problem or not is a good question. Especially if it's a lookup by name every time, so looking up by the type registry by name might come with a certain cost. I think we'll have to see. We'll have to see if this is going to be a problem or not, or and if there's sort of if we have to, what the best strategy is to go around that. Okay, last question from Gabriel.
How about functions? Could we have lookups?
Right, so the work that Olivier has done on the C++ side on implementing gadget like that also allows actually for not only declaring properties, but you can also declare invocable functions. And then you could have you could call those functions as well. And since we know what the type of this object is that it expects it to be, the member function, that should be doable. So my dream is actually that, well, it's not, yeah, my dream is that if you look at QPoint and QRect in Qt, they're currently just structures, and I'd like to actually to annotate them with QGadget, and the useful functions in there, annotate them with invocable, and let mock generate some data structures on the side that don't really affect the way you use QPoint and QRect in C++. But they will, because of the central registration, they'll make it possible for dynamic scripting environments like QML to use that and know about the layout of those structures, and then or helper functions basically. All right. So this should just work, I think. Last topic I want to talk about is the compiling QML feature or compiling QML files ahead of time. This is something that we've added in Qt 5.30. The basic idea is that it allows for faster execution of QML applications on platforms that don't support the JIT, such as iOS or such as MIPS. We don't support a JIT there, or ARMv5, for example. And it removes the need of shipping your QML source code with your potentially proprietary application. That could be an issue for some people. This is something that we can solve that way. And we found out that it actually improves the startup time, especially if you use a lot of JavaScript code. And this is shipping since Qt 5.3 in the commercial packages of Qt for the usual suspecting platforms. The basic principle of how it works is that it takes QML and JS files standalone and just looks at them and takes them as input from your QRC files. So you have to design your application as if it was standalone and would just ship all of the QML and QMLDir files and JS files inside the application through the Qt resource system. And then the QML compiler will go ahead and pick out the QML and JS files and compile them. And it will compile them to C++ code. It will generate C++ code, and that C++ code will then be run through the compiler that you've actually chosen for Qt. So it'll use whatever cross compiler you have or whatever your current compiler is anyway. But the Qt Quick compiler generates C++ code, Qt-style C++ code. So demo time. I'm just going to quickly show how this looks like and works, just to give you a bit of an idea. So what I have here is the same game. Just to prove you that it's really the same game, I'm just going to build it here and run it. There we are. This is the game. I have to really resist the temptation of finishing this round. It really shouldn't take long. Anyway, okay. Anyway. So all we need to do currently, and in the future, I think we'll probably have a nice checkbox or something in Qt Creator for that. Maybe right below the enable QML debugging or so. But until you see that checkbox appearing, you need to write something here in order to, instead of running it with dynamic QML, you compile it ahead of time by writing config plus equals Qt Quick compiler. And that's really it. So after that, I press Control B, and then it starts building here. Now, if you look at the compile output here at the bottom, it does take a little longer now because it's compiling files that look like, where the file name is quite similar to the name of the QML and JS files. And that should only take a second. Or, well, it will take a bit longer because now we're running the C++ compiler. But it finished, and if I run it, it's still the same It's exactly there shouldn't be really any difference, and I don't think there is. But the only absolutely reliable way of finding out is to finish the level, because then we know if no. Anyway, believe me, there isn't a difference. So, right, one thing I could show is like on the save game what the difference, for example, is. So if I go back to not compiling this ahead of time, suppose I want to benchmark this thing. So I'm going to do, just to show you, I'm going to change something here. This is the same game QML file, and I want to show you what impact this has on startup performance. So what I'm going to do is I'm going to change the game to, instead of bringing up the window, is that right after it finished loading, it should just quit again. So I can just run it and it quits, and then I can measure startup time. So I'm going to just do a timer here, because it does show, so it's a bit awkward, but never mind. Running true, and then on triggered. Wait, this should be true. And then I do queue.quit. I can't really do component uncompleted quit here, because that'll be called when this thing has been created. But the same game creates the object and then spins the event loop, so it will not quit, won't do anything, it'll go into the event loop. So I have to do a timer that will fire once we're inside the event loop. But does not have any impact on startup time, believe me on that one. So if I just compile this now, well, there's not much to compile actually, because I removed the support for the compiler. If I go onto the terminal here, terminal, where are you? So I'm in the directory here, and if I run the same game, if I run the same game here, it's going to come up and quit right again. So if I ran this, for example, now to perf start same game, we can see that this takes roughly 528 million, thank you, instructions. We can run again just to see that this is sort of roughly the same ballpark, 559 million. Close enough, I would say. So this is without the QML compiler. And if we did the same thing with the QML compiler, this is just to start it up, right? Git quick compiler. And building. Right. The C++ files were already there from the previous build, so it was a bit quicker now. So this is the one, 559, remember? And now does it still work? Or at least, yeah, something happens. Perf start, same game. And we can see, oh behold, it's only 380 million instructions, which is roughly 30% less instructions just to start it up. So for the same game, we just saved 30% of the instructions required to fire up the application. And that is sort of a quick win if all you need to do is type config plus equals something, or in the future, have a checkbox maybe. Yeah, I've been told that I need to implement it myself now. Yes. But I know. I should give it a shot. Yeah, what else can I show you? I have a bit of time. Yeah, I can show you the generated code, actually, how it looks like, if you're curious. So, if you take, for example, SameGame.js, let's look at this function here, index. This is not a very exciting function, but it calculates, as you can see, it calculates an index in an array, or in a table, actually. So column times row times the dimension, number of columns. And if you want to look at what the Qt compiler does for that, I'm going to peek into the compiler directory, and then there's content SameGame.js. So the name of this file is almost the same as the JS file. And this index function, I'm going to search for it. So this is going to be a bit messy on the screen. Yeah, this should be the one. So this is the function that we generate out of it, and you see there's there's one line of JavaScript, massive amount of C++ code. And it looks really weird. But this has to, nevertheless, simulate what happens in a JavaScript environment. So it it has to behaviorally be absolutely identical to how code executes in JavaScript. That's why it may look a little weird. But nevertheless, we try to get away from, so there's lots of code and oh, it stops right here actually, it's not too bad. Sorry. But what you have to remember if you end up looking at this generated code is that it looks a bit verbose, but the compiler is doing actually a pretty damn good job at optimizing things away. So this is something that looks verbose, but the resulting output is actually relatively small and compact. And we can do even things as to leaving the JavaScript environment in case we already know that certain types have so for example, in this calculation, we know that the result is a double. We're multiplying two numbers, or we're doing multiplication. The result of a multiplication is a double. So we can actually leave the JavaScript world and create C++ types, like a double on the stack.
Got an even question. Why can you multiply values directly, but for adding values you have to call runtime times?
Yes, good question. This is, in fact, not how it's supposed to be in the long run. But the part of the problem is that with a multiplication, we know that the standard says the result of a multiplication is a number. And a number is a double. But the result of an addition does not have to be, you can add two strings and the result won't be a number. That would be kind of awkward. So that is why, if you go back to the generated code, there is some oddly looking stuff here. There's a call to runtime add. This is the addition. But if this was running in an environment where we know more of the types and we knew that the result of the multiplication is a double, we knew the other side was also double, then the generated code would not actually be a call to the runtime. But for the multiplication, we actually do a regular C++ multiplication in the highlighted line here. Oh, people are leaving. That's a bad sign. So, only one more thing. One thing that we have changed, and that is interesting for the people who may have been using this thing before. As we released it with Qt 5.3, the compiler consisted of a program and a QMake integration, and also in 5.3.2 a CMake integration. And it also consists of a runtime library. And apps had to link against this runtime library. It contains some centralized shared code. And that made it difficult to use the Qt compiler on platforms where we didn't provide binaries for, like MIPS and ARM, and those ones that are particularly interesting, actually. So we fixed that with Qt 5.4. You're not going to need a runtime library anymore. Instead, the compiler generates fully self-contained C++ code. So if you want to use the Qt compiler on some weird Windows CE platform or something like that, then all you really need to do is you just grab Qt binary packages, commercial packages that run on on Linux, Mac, or Windows, and you could just take the Qt compiler, because that's a statically linked host binary, and you take the QMake or CMake integration files, pop them into your custom build of Qt for your target platform, and that's all you need to do. So there's no need for a runtime library anymore. That should make it easier. Okay, I'm being thrown out soon. Or no. I'll finish. It'll be a long sentence that will have lots of commas. We plan to make this thing much better and longer and quicker. Not only look at individual QML files, but I'd like to actually look at entire projects and detect dependencies and types, and be able to detect things like with the singletons. There's a read-only property, it's turning into a constant, inline it. There are some things that the compiler currently doesn't really do yet that we'd like to do in the future. Anyway, you can ask me about these things if you want. Brief summary of all the things I talked about. We're rewriting lots of stuff in QML, as you may have hopefully have gotten the impression of. We're changing a lot of things. Sometimes we unfortunately have to change the behavior a little bit, but we plan on ramping up on the API a lot, on the C++ integration, especially with the structures and things like that. That is going to be important in the future. And we're also going to continue to build up on the compiler. So, thank you very much for listening.